one train travels west toward Denver at 120 miles per hour. This is the diagram that shows you that the first train here is traveling west, so it's heading toward Denver at 120 miles per hour. A second train travels north away from Denver. So this train is actually going away from Denver. So it's leaving Denver and it's heading this way. First train goes toward Denver, second train heading away from Denver at 90 miles per hour. At time zero, at time zero means initially, the first train is exactly 10 miles east. So initially, this train is 10 miles away from Denver, and the second train is 20 miles away from Denver initially. Okay? Calculate the rate at which the distance between the two trains is changing. So as one move toward Denver and the other move away from Denver, this is the distance between them, and the distance between them will change. The reason is because these two trains moved at different speed. Okay, so let's begin by, we'll draw another diagram here without the train, and hopefully this will make the meaning a bit clearer. Here's the first train is coming toward Denver. The second train is going away from Denver. Initially, the first train is 10 miles away, and the second train is 20 miles away. The first train is traveling at 120 miles per hour. This stands for the speed of the first train. I use negative velocity because it's coming toward Denver. The second train, which is in the north direction, we call that the Y direction. It is leaving Denver, it's going away from Denver. So I'm going to say that it's going away at 90 miles per hour. Now, this is your Z value, which we don't know. Actually, we do know what Z is. Right now, the exact distance between these two trains can be found using Pythagorean theorem. So then, like, Z would equal to 20 squared plus 10 squared. So Z would equal to the square root of 400 plus 100, which is 500. So initially, the two train has a distance of 500. The two train has a distance of the square root of 500, which is how many miles? The square root of 500. It's about 22 miles. So initially, the two trains are 22 miles away from each other. One is coming toward Denver, the other is going away from Denver. The question is, how fast is the distance between them changing? Okay, so we begin by perhaps drawing a diagram and just writing down what we know, and we're gonna make it more formal here. So what we know here is that the first train has a speed of 120 miles per hour and is coming toward Denver. Its position at time zero, its position from Denver is 10. We also know that the second train that's going away is going away at 90 miles an hour. Its position is 20 miles from Denver. And we did this, but we also know that if these were the case, then common sense and Pythagorean theorem tells us that the distance between the two trains is 500, or the square root of 500 miles, which is about 22 miles. And that's all that we know. Now, what do we want? We want to know the speed or the rate at which the two trains are from each other. How fast are they going apart? One's going away, the other's coming toward them. So what is the rate? How fast is the distance between the two trains changing? This is what we want. Now we write down how they are related. So relate or related. In any problem that deals with or looks like a right triangle, we're always going to use the Pythagorean theorem identity, which is x squared plus y squared equals to z squared. So x squared plus y squared equals to z squared. And now we use common sense and we ask ourselves, will the distance in the x direction change over time? And the answer, yes, it will change over time. Therefore, x is a function of time. Will the distance in the y direction change over time? And the answer is yes, it will change over time. Therefore, y is a function of time. Will the distance between the two trains change over time? And the answer is yes, they do. So z is also a function of time. We wrote down the related equation, and now we differentiate. So differentiate. This is 2x of t times x prime of t plus 2y of t times y prime of t equals to 2z of t times z prime of t. Every term contains a 2, so you can divide everything by 2 and it will drop out. Also, to help reduce the notations, I'm going to drop the variable t, but I know that the variable t is within every function. So x is a function and y is a function. Keep that in mind. So again, I'm going to drop the number 2 and I'm going to drop the variable t. And if I do that, then here's what I have left. X times x prime plus y times y prime equals to z times z prime. How am I able to just remove 2? Because I divided everything by 2. I did not remove the variable t. T is the time variable, and there should be a t here, there should be a t there, there should be t, which is a function, y, which is a function of t. But I just don't want to write it down because it's just too many things to write. So I wrote that. And then now we go back to what we want. So what we want is how fast is the distance between the two trains changing. So I want this. So leave that alone and go back to what we know and plug that in. So what we know is that x equals to 10 and y equals to 20 and z equals to the square root of 500. So 10 times. We also know that the speed that the train is coming toward Denver is negative 120. We know that y is 20. We know that the speed of the second train going away is 90. Found out that z is 500. And here's our z prime. Okay, so multiply those together and then combine with that. So we're looking at negative 1200. Adding that to 1800 brings us to 600 equals to the square root of 500 z prime. So z prime equals to 600 over the square root of 500. And if we divide 600 divided by the square root of 500, we get about 26.833 miles per hour. In other words, at exactly, initially, the first train is 10 miles away, the second train is 20 miles away. One is coming toward Denver, the other one's going away from Denver. but the distance between them is changing at 26.8 miles per hour.